At the farthest reaches of the sky, where light grows thin and ancient, the universe fades into a quiet glow that our eyes can barely hold. Out there, at the soft frontier of visibility, the cosmos becomes a whisper, a horizon not of walls, but of time stretching into silence. Tonight we drift toward that distant boundary, the gentle, vanishing edge of the observable universe. Welcome to AstraFlow. Here, science drifts like starlight, and curiosity becomes calm. Tonight, let your thoughts slow down, your breathing find its rhythm, and your mind float through wonder. Before we begin, I'd love to know where you're listening from. Are you lying in bed under city lights, or watching the stars from somewhere quiet? Tell me in the comments. It's always peaceful to imagine the AstraFlow community scattered across the world, drifting together through the same sky. And if this calm journey brings you peace, you can gently support AstraFlow by liking this video or subscribing. It helps this little corner of the cosmos keep glowing. Now, let's begin tonight's voyage into the quiet story of the edge of the observable universe. Imagine your awareness resting on a calm, slow breath. A soft inhale, a long, unhurried exhale. As your body settles, the universe opens like a page in low light. When we speak of the edge of what we can observe, we're speaking not about a physical border, but about a boundary shaped by the oldest light still travelling toward us. It is a distance written in time rather than in space, an invisible horizon that expands as the universe continues to breathe. In the next moments, we'll drift outward from familiar stars, past spiraling galaxies and gentle arcs of light. We will travel through cosmic history the way one follows ripples across a lake, always moving outward, always sensing the moment when the ripple finally fades. The observable universe is such a ripple. It is the region of space where light has had time to reach us since the beginning. Beyond it, the cosmos continues, but its stories have not yet arrived. As we explore, let each idea move through you like a tide, slow, weightless, unforced. This is not a journey of speed, but of listening, to the silence between galaxies, to the delicate hum of starlight stretched across billions of years, and to the profound stillness waiting at the cosmic horizon. All you need to do is drift and breathe. Where does something as vast as the universe truly end? It's a question that feels almost impossible, like trying to find the edge of a breeze or the silence at the top of a wave. When we look up at the night sky, everything seems open, boundless, stretching far beyond the fragile limits of our imagination. And yet, our instruments, our light, and even our time place gentle boundaries around what we can know. The universe may be infinite, but our view of it is not. And that simple truth invites us into one of the most delicate questions in cosmology. What does it mean to live inside a cosmos whose farthest reaches we can never touch? As you breathe softly, imagine standing at the shore of a vast mist-covered ocean. You cannot see the other side, you cannot hear its distant waves, but you know, quietly, that the ocean continues beyond your sight. The observable universe is much like that. Its edge is not a wall, nor a cliff, nor a barrier. It is simply the farthest place from which light has had time to reach us since the universe first ignited with the Big Bang. Because the universe is 13.8 billion years old, you might think the edge should also be 13.8 billion light-years away. But space is not still. It stretches, expands, and flows outward like breath through an endless sky. As space has expanded, the distances between galaxies have grown, carrying ancient light farther and farther. Or what began as a small flash has been stretched across a river of ever-widening space. And so, the edge we speak of tonight lies far beyond 13.8 billion light-years. It rests roughly 46 billion light-years away, not because the light travelled that far in time, but because space grew beneath it. this edge is not a place we can reach. Not a destination, it is a horizon of understanding shaped by physics, time, and the speed of light. Every observer on every planet around every star carries their own horizon, each one a quiet sphere, centered on their existence, defined by the age of the universe itself. As you inhale gently, imagine that sphere expanding with your breath, smooth, luminous, and calm. With every passing moment, more ancient light travels toward you. More of the universe becomes observable, your horizon grows, but at the same time vast regions drift forever out of reach, carried away by expansion faster than any light can hope to chase. So where does the universe end? Perhaps nowhere at all. But where our vision ends, that is the boundary we drift toward tonight, slow and serene as the cosmos reveals itself one soft layer at a time. To understand the edge of what we can see, imagine the universe not as a flat picture painted across the sky, but as a softly expanding sphere of memory. Every point of light you've ever noticed, every star, galaxy, and delicate cosmic glow sits somewhere inside this sphere, and you stand at its center, not because you're special, but because every observer, everywhere in the cosmos, is placed at the center of their own observable universe. It is a natural consequence of light traveling outward in every direction, filling space with stories from long ago. Close your eyes for a moment. Imagine this sphere around you, calm and dim like a lantern lit from within. Its radius is not determined by distance alone, but by the age of light that has finally reached you. The observable universe stretches roughly 46 billion light-years in every direction, even though the universe itself is much older and larger. Light, moving at its steady pace, has been journeying toward us since the universe became transparent, long after its fiery beginning. Within this vast sphere are layers of cosmic time. Nearby stars offer us light only years or centuries old. Distant galaxies shine with a light millions, even billions of years old, and at the farthest edge of visibility lies the cosmic microwave background, the gentle afterglow of the Big Bang, a whisper from when the universe was only 380,000 years young. This afterglow forms the true outer shell of our observable map, not because nothing exists beyond it, but because no light from earlier moments can reach us. Before that time, the universe was a dense, glowing fog where photons were trapped, unable to travel freely. So the boundary we speak of tonight is more like a veil of time than a wall of space. It is the limit of what light can reveal. Beyond it, galaxies may shine, stars may form, and space may stretch into landscapes we will never witness. But their light, born across expanding space, has not yet reached us, and some of it never will. As you breathe gently, picture yourself floating within this sphere. Let your awareness drift outward from the Milky Way, through cosmic filaments, past clusters bound by gravity's quiet thread. The map is immense, but its meaning is simple. The observable universe is not a complete chart of existence. It is a slowly unfolding message from the past, shaped by distance, time, and expansion. This gentle map is our starting point. From here, we drift outward, step by step, toward the softly fading edge, where light grows ancient, where time thins, and where the known universe meets the unknowable. Light is the universe's quiet storyteller. Every photon you see tonight began its journey long before your breath reached this moment. Some left their homes only years ago, slipping from the surface of a nearby star. Others began travelling when early humans were carving symbols into stone. And some, the faintest, reddest, most delicate whispers, come from galaxies born when the universe itself was still young and unsteady, learning how to expand, cool, and shine. When you look outward, you're not seeing distance alone, you're seeing time. Light does not erase its past, it carries it gently, like a note held in a long, trembling breath. This is why astronomers often say that telescopes are time machines. Each improvement in sensitivity, every increase in mirror size allows us to see farther into the cosmic past. The farther away something is, the longer its light has been travelling, and the earlier the universe appears. Imagine drifting through space on a soft, slow current. As you move away from Earth, the familiar constellations fade, replaced by the cool glow of stars thousands of years old. Drift farther, and the Milky Way becomes a pale river of memory. Continue outward, gently, and the light around you stretches into older and older moments. 2 billion years back, 4 billion, 10 billion. Each step takes you through a younger universe, smaller, hotter, and more crowded with newborn galaxies. This is the magic of looking outward. The universe reveals its story in reverse. The nearer galaxies show the present, the distant ones show the past. And at the absolute limits of visibility, we see the universe when it was little more than a shimmering fog of particles. All of this happens because light moves at a fixed and patient pace. It does not hurry, it does not rush, it simply flows, wave after wave, across expanding space. And as it travels, space itself stretches those waves, pulling them into longer, redder tones, like a song slowly lowering in pitch. This gentle stretching, called redshift, becomes more pronounced the farther away a galaxy is, and so the colour of ancient light becomes a clue to its age and distance. Light is our bridge to what was, our only way to touch the universe's earliest mornings. And as you breathe in softly now, imagine each inhale drawing in a little of that ancient glow, a quiet reminder that you live inside a universe filled with memories billions of years old. In this journey, light guides us, like a lantern on a vast drifting sea. Every observer in the universe lives inside a quiet sphere of visibility, a boundary defined not by walls or edges, but by the patient travel of light. This boundary is called the cosmic horizon, the farthest distance from which any particle of light has had time to reach us since the universe began. Beyond it, the cosmos continues, perhaps endlessly, but its stories have not yet arrived. The horizon is simply the limit of what light can tell us. Imagine you are floating in deep space, held gently by silence. There is no up, no down, only a vast, smooth darkness. In every direction, the faintest whispers of ancient starlight drift toward you. Some of these photons have travelled for billions of years. Some began their journey before Earth even existed. Together they shape a glowing shell around you, a horizon of time. This horizon is not fixed. It expands as the universe ages. With every passing second, more ancient light completes its long voyage and reaches your eyes, your instruments, your awareness. The horizon stretches outward, as if your sphere of understanding grows with every quiet breath you take. But this expansion is not simple. Space itself is stretching. As it expands, distant galaxies drift away, carried like lanterns receding on a dark sea. Some drift so quickly, propelled by cosmic expansion, that the light they emit now will never reach us. They move away faster than light can close the gap, not because they are breaking cosmic laws, but because space is creating more space between us. This creates two boundaries, a particle horizon, marking how far ancient light has already reached, and an event horizon, marking how far future light will fail to reach. Both form a quiet geometry of knowing and not knowing. As you breathe slowly, picture these horizons as soft, overlapping shells. One shows everything the universe has revealed so far. The other marks the regions forever hidden, not by distance alone, but by the relentless flow of expansion. And somewhere between them lies the edge of the observable universe, a dynamic, gently shifting frontier shaped by time, motion, and light. The cosmic horizon reminds us of something tender and profound. We do not see the universe as it is. We see it as it was, filtered through the patient journey of light. And as we drift forward in this exploration, we will move toward regions where the stretching of space becomes so strong that even light slows into a fading whisper. The horizon becomes less a boundary of place and more a boundary of time itself. Let that idea settle over you like a calm, deepening dusk. One of the most surprising truths in cosmology is this: space itself can expand faster than light, and nothing about that breaks the laws of physics. It sounds impossible at first, as if the universe were ignoring its own rules. But the rule that nothing can travel faster than light applies only to objects moving through space, not to space itself quietly stretching, widening and flowing outward like an endless tide. Imagine drawing dots on a balloon. As the balloon inflates, the dots drift apart. The dots are not moving across the surface. The surface is simply expanding beneath them. This is how galaxies behave on cosmic scales. They are not rushing away through space with impossible speed. Instead, the fabric of space between them is growing. And when that growth is fast enough, galaxies can recede from us faster than any light they emit can catch up. This creates a strange but beautiful situation. There are galaxies we can see because their ancient light left them billions of years ago, but we will never see the light they emit today. That new light is trapped on the wrong side of expansion, carried away before it has any chance to approach us. As you breathe softly, imagine drifting in a quiet ocean whose current flows outward from every point. The current grows stronger with distance. Nearby galaxies drift away gently, like leaves on calm water. Farther galaxies drift away more quickly, and those near the farthest regions of the observable universe are swept outward so rapidly by expansion that even light, our fastest messenger, cannot swim upstream. This does not violate cosmic speed limits, because the galaxies themselves are not pushing through space. The space between us is simply stretching faster than light can cross it. It's the difference between running down a hallway and having the hallway itself elongate faster than you can run. This phenomenon hints at something profound. The observable universe is not a record of everything that exists, but only of everything that has managed to send its light to us before expansion carried it too far. Beyond our horizon, uncountable galaxies drift into permanent darkness, not because they are gone, but because their messages can no longer reach us. As the universe continues accelerating under the influence of dark energy, more galaxies will cross this threshold, disappearing from our observable realm the way distant ships vanish into fog. Not abruptly, but slowly, softly, like a final note fading into silence. Hold this idea gently. The universe is full of places we will never see, not because we are small, but because space itself is always flowing outward, carrying everything with it in a quiet, unstoppable tide. When we gaze into the deep sky, we're not just looking far away, we're looking back in time. Every distant shimmer carries us through layers of cosmic history, each one older and fainter than the last. The farther we look, the younger the universe becomes, until eventually, at the edge of visibility, we encounter a cosmos only moments after its birth. Imagine lifting a lantern in a quiet forest at night. The nearest trees appear sharp and clear. Those farther away soften into silhouettes, and the farthest dissolve into fog, where shape becomes memory. The universe behaves in a similar way. The nearer galaxies show us the present universe, mature stars, sprawling spirals, and calm clusters shaped by billions of years of gravity. But as we peer deeper, past billions of light years, the galaxies grow smaller, dimmer, and more fragile. Their shapes are irregular, like sketches of what galaxies would later become. At 13.8 billion light-years of the look-back time, we approach the dawn of cosmic structure. we see galaxies forming when the universe was only a few 100 million years old. Fragile collections of new stars burning hot, bright, and quickly. They flicker with the intensity of youth, their light stretched into faint red hues by the expansion of space. These galaxies are ancient in distance, but newborn in age. Their photons began travelling toward us when Earth was only a dream in the future. Those photons passed through expanding space, through cosmic web filaments, through vast voids and clusters, until finally they arrived at our telescopes. Tiny messages carried across nearly the entire age of the universe. As you breathe softly, imagine receiving that light. Feel its age, feel its journey. The universe is not simply large, it is old, and every distant glimmer is a time capsule, offering us a rare glimpse into the earliest chapters of cosmic evolution. But even this deep look back does not reach the beginning. Before the first stars, before the first galaxies, the universe was still too dark and too young for light to travel freely. When we look past 13.8 billion years of look-back time, we encounter not light but silence, an era where the cosmos was filled with dense plasma, glowing but opaque, like the inside of a cloud. And so, the edge of our vision becomes a doorway into a universe long gone, a younger cosmos smaller and hotter, revealed to us only through the faintest whispers of ancient light. As we continue outward, we move beyond galaxies entirely. We drift toward the oldest visible glow in existence, the soft, fading afterlight of the universe's first dawn. At the very frontier of our cosmic vision, where space is stretched so far that light arrives as a faint red whisper, we discover the most distant galaxies ever seen. These galaxies are not grand spirals like our Milky Way. They are small, fragile structures, glowing embers from the universe's early youth. When we see them, we are witnessing a time when the cosmos had barely begun to form stars. Imagine drifting outward from the Milky Way, passing through clusters and filaments, crossing billions of years of look-back time. The galaxies grow younger, their shapes grow simpler. Eventually the familiar spirals disappear, replaced by faint scattered knots of starlight. These are the earliest islands of matter in a universe still finding its rhythm. Among these distant objects, astronomers have detected galaxies with redshifts of 10, 12, even up to around 13, meaning their light began its journey when the universe was less than 400 million years old. That is roughly 3% of its current age. Their stars were among the first to ignite after the long cosmic dark age, when hydrogen gas cooled enough to allow light to escape freely. These distant galaxies are astonishingly bright for how young they are. Their stars burn hot and fast, creating intense ultraviolet light that the expansion of space stretches into soft infrared waves by the time it reaches us. Telescopes like Hubble and JWST capture this ancient glow, revealing galaxies that look like tiny sparks frozen far down a long dark tunnel. As you breathe gently, picture these galaxies as fireflies at the edge of vision, blinking softly in the earliest cosmic night. Each one is a clue to how the universe assembled itself, small clumps merging, growing, and shaping the large-scale structures we see today. But even these galaxies do not mark the true edge. They are simply the farthest that our instruments can currently detect. There are almost certainly countless galaxies beyond them, too faint or too stretched by cosmic expansion for their light to be seen. Some lie beyond our horizon entirely, in regions where expansion outruns light's ability to cross space. The farthest galaxies we observe serve as delicate milestones on our journey outward. They show us the universe's adolescence, bright, turbulent, hurried. They allow us to watch galaxies forming stars at astonishing rates, reshaping gas into the first luminous structures, and yet, these are only the visible outskirts of an unfathomably larger cosmos. Beyond them lies more darkness, more distance, more silence. until finally even the earliest galaxies fade into the background glow of the universe's first light. We are approaching that glow now, the softest, oldest light in existence. Every wave of light carries a signature, a rhythm, a colour, a quiet story about its journey through space. But the farther that light travels, the more the universe reshapes it. As space expands, the waves stretch, lengthening like a slow exhale. Their colour shifts toward the red end of the spectrum. Their energy softens, their message becomes faint, delicate, almost shy. This gentle transformation is known as red shift, and it is one of the universe's most eloquent whispers. Imagine blowing a soft note across the surface of a lake. As the ripple travels outward, it widens, its crest becoming smoother, calmer. The ripple carries your message, but its shape changes with distance. Light works the same way. A photon born blue and energetic can arrive at our telescope stretched into a faint warm glow, a story still intact, but altered by the space it crossed. When astronomers measure redshift, they are not simply observing colour, they are reading the universe's expansion. A galaxy with a slight redshift is relatively close, its light only modestly stretched. But a galaxy with extreme redshift, 10, 12, 13, reveals a time when space was smaller, denser, and expanding more rapidly. These high redshift galaxies push the boundaries of our cosmic sight. Redshift is more than a tool, it is a quiet map of distance and time. The farther away something is, the longer its light has travelled, and the more it has been stretched by the growth of space. This stretching allows us to estimate not only how far that object lies, but also how old the universe was when the light first began its journey. As you breathe gently, imagine each inhale gathering the softest of these stretched photons. Ancient light, cooled by billions of years of cosmic drift. A single redshifted photon that reaches you tonight may have been travelling since long before the Earth formed, slipping through a universe that has grown and changed around it. The redshift whisper also explains why the most distant galaxies appear so faint. Their light has been stretched to wavelengths our eyes cannot see, slipping into infrared bands that only sensitive instruments can detect. Telescopes like JWST peer into these wavelengths, revealing objects once hidden behind the veil of time. There is a quiet beauty in this process. Redshift reminds us that the universe is not static, not frozen, but alive with motion. Everything is drifting, stretching, unfolding. Even the light that reaches you is shaped by the journey it took. And as we drift outward on our exploration, redshift guides the way. A soft voice telling us how close we are to the oldest visible light in existence. Beyond the most ancient galaxies, past the faintest redshifted whispers, lies a glow that fills the entire sky, a soft, uniform radiance older than any star. It is not the light of galaxies, nor the afterglow of explosions, but the lingering warmth from the universe's first dawn. This is the cosmic microwave background, or CMB, the oldest visible light in existence. It is the closest thing we have to a photograph of the infant universe. Imagine drifting outward until galaxies fade behind you, their shapes dissolving into faint smudges suspended in darkness. As you go farther still, the universe does not grow darker. Instead, a gentle glow emerges, dim, even, and omnipresent. Not bright, not sharp, but comforting, like the warmth of embers beneath thick ash. This is the light released when the universe was only about 380,000 years old, a time when space was still young and filled with a dense warm fog of particles. Before this moment, the universe was opaque. Photons collided constantly with free electrons, unable to travel more than a tiny distance before being scattered again. It was a cosmic storm of light, trapped in plasma. But as the universe expanded and cooled, electrons joined with protons to form neutral hydrogen. Suddenly photons were free to move, and the universe became transparent for the first time. Those first escaping photons have been travelling ever since. More than 13 billion years of journeying through expanding space stretched again and again until their once hot glow now rests in the microwave part of the spectrum. We cannot see this light with our eyes, but sensitive instruments reveal it as a faint wash across the entire sky. A soft cosmic cradle song, echoing the universe's earliest breath. As you breathe slowly, imagine touching this ancient glow. It is everywhere around you, in every direction, at every moment, filling the cosmos with a uniform warmth only a few degrees above absolute zero. But the CMB is not perfectly smooth. It carries tiny ripples, slight variations in temperature and density. These ripples are the fingerprints of primordial structure, seeds that would eventually grow into galaxies, clusters, and the grand cosmic web. The CMB forms the farthest edge of what we can see, not because nothing lies beyond it, but because no earlier light can reach us. Its glow marks the moment where visibility begins, a luminous shell surrounding the observable universe. To look at the CMB is to look at the universe's childhood, soft, simple, shimmering with possibility. It is the outermost lantern on our journey, guiding us toward the very limits of time and light. Before the universe released its first free light, before the cosmic microwave background began its long journey toward us, the cosmos existed in a state where photons could not travel freely at all. It was a time of glowing density, a time when light was trapped in a thick, swirling fog of charged particles. To understand this era is to step into the universe's earliest memories, a place where brilliance existed but could not yet be seen. Imagine being wrapped inside a cloud so dense that even the brightest lantern disappears inches from your face. No matter how intensely light shines, it cannot escape the scattering mist. That was the universe during its first 380,000 years. A hot plasma filled all of space. Electrons drifting freely, protons and neutrons moving with restless energy, photons bouncing endlessly among them like sound waves trapped inside a drum. Every photon attempted to travel, only to be deflected again and again. The universe glowed fiercely, but no structure, no detail, no direction could emerge from the haze. Light existed, but vision did not. It was a cosmos without transparency, without stars, without galaxies, a sea of particles waiting patiently for the moment when temperatures would fall enough for order to begin. As the universe expanded, it cooled. Cooling led to calm. Calm allowed particles to slow, to join, to combine. Electrons found protons, forming the first neutral hydrogen atoms. And in that instant, something remarkable happened. Light was freed. No longer scattered by charged particles, photons could finally travel in straight lines. The universe blinked open, revealing itself for the first time. This transition, called recombination, is the moment when the fog lifted. It is the moment that created the cosmic microwave background we see today. The photons released then have been journeying across the expanding cosmos ever since, stretched into calmer wavelengths by billions of years of cosmic growth. As you breathe softly, imagine drifting through that early fog. Feel its warmth, its brightness, its restless motion. Then imagine the fog thinning, the glow softening, the first clarity emerging from the haze. The universe took its first gentle breath of transparency. It was the beginning of the cosmos as we know it. The moment when the seeds of structure could finally begin to grow. Before light could travel, the universe was full of potential but empty of vision. After that moment, the cosmos became legible, revealing a path for stars, galaxies, and the grand architecture of space. We drift now toward that transition point, the surface of last scattering, the oldest visible boundary of all. The universe's earliest visible moment forms a delicate shell around us, a vast spherical boundary called the last scattering surface. It is not a wall, nor a place we could ever physically reach, but rather a moment in time frozen into the fabric of space. When we observe the cosmic microwave background, we are seeing the universe as it was in that instant when light first became free. Imagine standing inside a softly glowing sphere, its surface stretching in every direction to a distance of 46 billion light-years. The light that paints this sphere came from all points equally, travelling toward us for more than 13 billion years. It is as though the universe wrapped itself around you with a faint, warm glow, a cradle of ancient light marking the moment visibility began. Before this moment, the cosmic plasma was opaque. After, it was transparent. The boundary between these states is the last scattering surface, the place where the final interactions between photons and charged particles occurred before the universe cleared. Each photon we detect today is a survivor of that moment, carrying one last imprint of the dense, rippling plasma that filled the young cosmos. As you breathe gently, imagine drifting toward this surface. You do not approach it like a wall. You approach it like a memory. Even if you travelled through space at light speed, you would never reach it, because it recedes as time passes. The light we see today from that early moment comes from regions that were once much closer, but as the universe expands, the origin of that ancient light drifts farther away. The surface is always out of reach, always the same age, always moving. If you could touch it, you would feel a universe still warm, around 3000 Kelvin, glowing like a coal slowly dimming. You would sense tiny ripples in density, slight variations of temperature, no more than a few tens of microkelvins above or below the average. These subtle patterns became the seeds of everything we observe today. Galaxies, clusters, cosmic filaments, even the space where you now rest. Every tiny fluctuation is a whisper from the beginning, the earliest clues about how matter arranged itself after the Big Bang. When we map the CMB, we are tracing the imprints of those primordial ripples across the entire sky. The last scattering surface is the true outermost shell of our observable universe, not because the cosmos ends there, but because earlier light cannot reach us. It is the oldest image the universe offers, a moment of sudden clarity stretching across all of space. As we drift onward, we move from this first visible moment into a deeper mystery. How the universe expanded so rapidly in its earliest fractions of a second that these ripples were stretched across unimaginable distances. Before the universe became transparent, before the first atoms formed, before light could finally drift freely across space, something extraordinary happened. Something so rapid, so expansive, so silent that we can only describe it in metaphors. This event is known as cosmic inflation, a moment when the universe expanded faster than anything we can picture, stretching space itself in a single, breathtaking surge. Imagine the entire observable universe, everything you can see, everything telescopes can detect, every star, galaxy and distant glow, compressed into a region smaller than a grain of dust. Then imagine that grain inflating nearly instantaneously, not into something the size of a city or a planet, but into something far larger than any galaxy cluster today. Inflation did not simply expand the universe, it smoothed, cooled, and flattened it, setting the stage for everything that followed. As you breathe slowly, picture the universe taking its own first breath, a moment of rapid, almost dreamlike expansion that lasted for an unimaginably short fraction of a second. During this breath, tiny quantum fluctuations, minuscule ripples in the fabric of space, were stretched to cosmic scales. These ripples became the seeds of the large-scale structure we see today, the clusters, voids, filaments, and galaxies woven across the cosmic web. Inflation explains why the cosmic microwave background looks so uniform and calm. It explains why distant regions of the universe appear to share the same temperature, even though they are too far apart to have exchanged heat or light. Inflation pushed them apart after smoothing them into equilibrium, like stretching a warm cloth until it covers an entire room. What makes inflation so mysterious is how quietly it happened. It produced no sound, it produced no light. It left behind only subtle fingerprints in the CMB, faint, ancient patterns that scientists study like archaeologists brushing dust off a fragile artifact. And yet, without this moment, the universe would be wildly different, clumpy, chaotic, uneven, and unable to form the elegant structures we see today. Think of inflation as the universe's first great exhale, a widening of space so sudden and profound that it outpaced even the speed of light, though not by breaking cosmic rules. Light sets the speed limit for motion through space, but inflation stretched the space beneath everything, carrying all points outward in a smooth, unstoppable flow. Let yourself imagine this breath as a soft pulse, expanding, smoothing, preparing. A moment of unimaginable speed that left behind a universe capable of calm, order, and light. Inflation is the quiet prelude to everything visible. A single breath that shaped the entire cosmic story. Even as we explore the vastness of the observable universe, we must remember something quiet and profound. Most of the universe lies forever beyond our reach, not because it is hidden behind walls or wrapped in mystery, but because its light will never have the chance to reach us. Space expands too quickly, and the cosmos is too young for those distant places to share their stories with us. This is the unreachable universe, a realm that exists but will remain forever unseen. To imagine this, picture yourself standing on a shore at night. The ocean stretches into darkness, infinite and silent. Waves near your feet are crisp, illuminated by moonlight. Farther out, the water is darker, calmer, unreachable. You know the ocean continues, but no light returns from the deepest horizon. The universe behaves the same way. The observable universe is the part of the cosmic ocean whose waves of light have reached us since the Big Bang. But far beyond this shimmering boundary are regions receding so swiftly that even their earliest light is swept away from us. These galaxies, clusters, and worlds are not hidden. They're simply being carried faster than light can close the distance, drawn outward by the accelerating expansion of space. As you breathe softly, imagine those distant realms drifting away, carried on the smooth, silent tide of cosmic expansion. Their light stretches, fainter and redder, until it vanishes into wavelengths too long to detect. Then even those waves fade, unable to overcome the widening gulf. This unreachable universe is vast, far larger than our observable sphere, perhaps infinite. Perhaps varied in ways we cannot imagine, with galaxies arranged differently, with stars we will never see, with structures so remote that they may belong to chapters of cosmic evolution we cannot access. And yet, there is no sadness in this. Nothing is lost. Nothing is missing. The universe does not owe us visibility. It simply unfolds, expanding gently, carrying distant places into permanent twilight. The existence of the unreachable universe reminds us of a fundamental truth. Observation is not the measure of existence. Just because light cannot reach us does not mean something is gone. It simply drifts beyond the horizon of what our senses can hold. This unseen realm also invites a quiet humility. We are not the centre of the universe, only the centre of our observable bubble. Every galaxy, every star, every planet has its own bubble, its own horizon, its own unreachable sky. The cosmos is far larger than what we can perceive. And there is beauty in knowing that some mysteries remain untouched, serene, and distant, like stars submerged beneath an endless sea. One of the quietest and most beautiful truths about the observable universe is this: its boundary is not fixed. It moves. It expands. It grows with every passing second, just as surely as your breath rises and falls. The edge of what we can see is not a rigid limit, but a shifting horizon. A frontier where ancient light is finally reaching us after billions of years of silent travel. Imagine standing on a wide plain beneath a dim sky. Far in the distance, a faint glow lies just at the edge of vision. With each step you take, the horizon appears to move with you, always at the same distance, always just beyond reach. But in the universe, something more subtle occurs. You do not move toward the horizon. Instead, the horizon comes to you. The light from galaxies that was once too faint or too distant now has had enough time to arrive. A photon emitted 13 billion years ago may finally be brushing against our detectors tonight, completing a journey older than Earth itself. And so, the boundary of what is visible slowly stretches, not because space itself contracts, but because time allows ancient messages to reach us. As you breathe gently, imagine that boundary expanding with your inhale. Smooth, effortless, natural. The universe is not rushing. It simply reveals itself at its own pace, a timeline written in light. Yet this expansion is not simple. Even as new regions of space become visible through the arrival of ancient light, other regions slip away from us. The accelerated expansion driven by dark energy pushes distant galaxies outward faster than their light can travel back. This creates a delicate balance. The observable universe grows because more old light arrives, but the reachable universe shrinks because new light cannot overcome the expansion. Think of it like watching lanterns float down a river. Some lanterns drift close enough for you to see their glow. Others move too quickly, swept away before their light reaches you. You witness only a fraction of what exists, a moving window through which the river reveals its passing lights. The expanding boundary of the observable universe carries a message both humbling and serene. The cosmos is not static. It changes, evolves, and unveils itself gradually. Every moment is a new opportunity for ancient light to complete its journey, and as our instruments grow more sensitive, we continue to peer slightly farther, gathering photons that whisper of times long gone. But even with perfect technology, there will always be a limit, a boundary beyond which the universe remains unseen, simply because time has not yet allowed its light to arrive. The edge of visibility is a breathing horizon, a cosmic boundary shaped by patience, distance, and the steady flow of time. As we drift farther toward the edge of the observable universe, a subtle and melancholic truth begins to unfold. Many of the galaxies we see now will someday vanish from view, not because they disappear, but because the expansion of space will carry them beyond the reach of their own light. They will fade softly into darkness, slipping past a horizon shaped not by distance alone, but by the accelerating growth of the cosmos. Imagine watching lanterns floating down a widening river at dusk. Near you, their glow is steady and warm. Farther away, their light shimmers like distant dreams, and eventually, the river widens so much that their glow falls below the horizon, not extinguished, but out of sight forever. Galaxies behave the same way. Their light travels toward us, but the space between us grows faster still. Some galaxies are already receding at speeds greater than light can overcome, carried by cosmic expansion rather than motion of their own. As you breathe softly, picture a quiet sky gently thinning over unimaginable stretches of time. Galaxies that shine brightly today will someday drift into invisibility, their light stretched beyond detectability by the swelling fabric of space. Their ancient photons may still travel toward us, but every new photon they emit is carried away faster than it can close the gap. Eventually, even their ghost-like signals will fade, leaving nothing but silence in their place. This does not mean the galaxies cease to exist. They continue forming stars, shaping worlds, and moving through their own cosmic histories. but from our perspective, they become unreachable, slipping beyond the cosmological event horizon. Their stories continue without us, like chapters in a book we can no longer turn to. Over trillions of years, this effect becomes even more profound. The observable universe will grow smaller in terms of what remains visible. Distant clusters will vanish. Filaments of the cosmic web will blur into darkness, and only the nearest galaxies, the ones gravitationally bound to us, will remain in our sky. Our cosmic neighbourhood will become an island surrounded by a vast, silent ocean of unobservable space. But this knowledge brings not sorrow, only perspective. It reminds us that everything we can see is temporary, a momentary gift offered by the interplay of light and time. The night sky itself is a passing scene, a cosmic lullaby composed of stars and galaxies sharing their light with us while they can. As you exhale, imagine those distant galaxies glowing softly, drifting outward with quiet dignity. Their departure is gentle, inevitable, natural, a reminder that in a flowing universe, even visibility has its tides. Some galaxies shine into our eyes for a moment in cosmic time. Then they slip gracefully into the dark beyond sight. There is a horizon in our universe where observation itself reaches its limit, a boundary beyond which no signal, no photon, no whisper of information will ever arrive, no matter how long we wait. This threshold is known as the cosmic event horizon, and it marks the end of observational possibility. It is not a place where the universe stops, but a place where our connection to certain regions fades permanently. Imagine sitting at the edge of a quiet lake at night. Near the shore, the moon's reflection ripples brightly. Farther out, its shimmer softens, and at a certain distance the lake becomes too dark, too wide, too still for light to return. The cosmos has a similar boundary, a limit beyond which space expands so swiftly that light emitted today can never bridge the widening gulf. This event horizon is different from the observable boundary we've already travelled through. The observable universe shows us the past. Light emitted billions of years ago that has finally reached us. But the event horizon governs the future, how far new signals can travel from this moment onward. Regions beyond that horizon are not invisible yet. We may still see them as they were billions of years ago, but any light they emit now or in the future will never reach us. As you breathe slowly, imagine space as a vast stretching ocean. Some waves roll toward you, carrying old light from ancient stars, but other waves begin too far away, swept backward by currents faster than they can move forward. Those waves will never reach the shore. This is the essence of the event horizon, the point where expansion outpaces communication. What lies beyond this horizon continues its own cosmic story, forming stars, colliding galaxies, shaping worlds. But all of these events remain forever disconnected from us. They are not hidden by distance or darkness, but by the unstoppable flow of space itself. In the far future, this boundary becomes even more absolute. As dark energy drives the acceleration of expansion, more galaxies will cross the event horizon. Their light will stop arriving, their glow will fade, the night sky will thin, leaving only the galaxies gravitationally bound to us, our local group, still visible. This slow erosion of the observable cosmos is not a loss, but a reminder. Our vision of the universe is shaped by time, motion, and light. We witness only the part of the cosmos that still has the ability to speak to us. The end of observational possibility is not the end of the universe. It is simply the end of our shared dialogue with distant regions whose stories continue without our eyes upon them. Let this idea settle gently. The universe is vast enough that some of its beauty drifts forever beyond reach, and yet what remains visible is more than enough to fill us with wonder. As we drift toward the vast edges of the observable universe, the grandeur of galaxies and clusters slowly gives way to something quieter, deeper, and far more mysterious: the enormous cosmic voids. These regions stretch across hundreds of millions of light years, yet contain almost nothing at all. No clusters. Few galaxies, only the faintest trace of matter drifting through immense silent expanses. They are the great empty chambers of the cosmos, calm, dark, and nearly still. Imagine standing in a wide desert under a moonless sky. The air is still, the horizon is empty, and the silence feels so complete it becomes a presence of its own. Cosmic voids carry this same feeling, magnified to unimaginable scales. They are not chaotic or violent. They're gentle, quiet spaces shaped by gravity, drawing matter outward into denser regions, leaving behind oceans of near-nothingness. The voids are not completely empty, but they are astonishingly sparse. Where a typical region of space might hold galaxies woven into threads and filaments, a void may contain only a handful scattered across distances so huge that each galaxy feels almost alone. Light crossing such a region takes ages to arrive, and when it does, it carries the stillness of that long solitary journey. As you breathe slowly, imagine drifting through a void. The last bright galaxies fade behind you, until you're surrounded by a darkness so deep it feels almost liquid. The nearest star might lie hundreds of millions of light years away. There is no gravitational pull to guide you, no clusters glowing faintly in the distance, just silence, a cosmic breath held for eons. But this emptiness is part of the universe's delicate balance. The dense regions grow denser, the empty regions grow emptier. This natural separation creates the large-scale structure of the cosmos. Filaments, walls, clusters, and between them, these immense voids. Without voids, the cosmic web would not exist in its beautiful, intricate form. The voids are like the spaces between notes in a melody, not meaningless gaps, but essential elements that give the universe its rhythm. The silence of cosmic voids also offers a unique perspective on distance and time. A single photon travelling through such emptiness experiences no interference, no scattering, only the gentle stretching of space. The light that crosses these voids arrives smooth and unbroken, carrying the purity of its long transit. In these vast, dark regions, the universe feels almost contemplative. No rush, no chaos, just the quiet expansion of space, unfolding steadily across unimaginable emptiness. And yet, even here, in these seemingly vacant realms, the structure of the cosmos is shaped. Voids help sculpt the edges of galaxy clusters and filaments, guiding matter into patterns that create the universe we know. The voids teach us that silence is not absence, it is space, it is balance, it is part of the cosmic story, as essential as stars themselves. When we imagine the observable universe, it is easy to picture something vast and formless, a scattering of galaxies floating without structure in endless darkness. But the truth is far more elegant. The part of the cosmos we can see has a very specific shape, a sphere centered on us, defined not by where we stand, but by the light that has had time to reach us since the beginning. Every observer, no matter where they live, sees a similar sphere. This shape arises not from our position, but from the flow of time itself. Imagine a lantern glowing in the center of a dark field. The light spreads outward in every direction, forming an expanding sphere of illumination. If you paused the scene at any moment and traced the reach of that glow, its boundary would always be a perfect sphere. Now reverse the idea. Instead of light spreading outward from you, imagine light traveling toward you from the distant cosmos. Everything you can see lies on the inside of that spherical shell of arriving photons. It is a sphere not of matter, but of visibility. As you breathe gently, picture this sphere around you, smooth, expanding, luminous with ancient information. It stretches roughly 46 billion light years in every direction. Not because we stand in a central cosmic location, but because the speed of light and the age of the universe create this natural geometry. This sphere is layered with time. Nearby regions show the present universe. Farther regions show earlier epochs. At the outer shell, we see the universe as it was only 380,000 years after the Big Bang. Every distance corresponds to a different moment in history, like tree rings radiating outward from the present. The shape also reveals something subtle. Our observable universe is not centered on Earth, because Earth is special. Every galaxy, every star, every conscious being anywhere in the cosmos has their own sphere of visibility. Each is centered on their location, not in a privileged way, but as a consequence of how light travels through time. This also means something profound. There is no single, universal edge of the universe. Each observer sees their own horizon, shaped by their own light cone, the paths light can take through space-time to reach them. The cosmic boundary is personal, shifting with time, expanding as ancient photons complete their long journey. As you exhale slowly, let this idea settle. We do not stand at a unique vantage point. We simply exist within our own sphere of light, the way every being in the cosmos does. The shape of what we can see is the shape of our past. A glowing sphere woven from photons that left their origins billions of years ago, now arriving softly to tell their stories. The universe is not centered on us, but our view of it always is. One of the most counterintuitive truths in cosmology is that the universe has no center. There is no special point from which everything expands, no privileged location from which the cosmos grows outward. Instead, every region of space expands away from every other region, like dots on an inflating balloon. From any vantage point, whether in the Milky Way or a distant galaxy billions of light years away, the universe appears to expand around you. Imagine watching snow fall in still air. No matter which flake you choose to focus on, the others drift away from it. From the flake's perspective, it seems as though it sits at the center of all motion. But of course, none of them truly occupy a center. The space between them simply grows. The universe behaves in this same beautifully democratic way. Every galaxy sees others receding, and each one could believe it is central, even though the expansion is uniform everywhere. As you breathe softly, imagine this expansion not as an explosion from a single point, but as a quiet stretching of space itself. The Big Bang did not occur in space, it created space. It was not the detonation of a cosmic fireball in a dark void. Instead, it was the sudden appearance of space-time, everywhere at once, followed by its smooth and continuous swelling. If the universe has no center, then what does the edge of the observable universe truly mean? It means that our visibility is limited by the age of the light reaching us, not by a physical boundary. We stand at the center of our observable sphere not because we are special, but because light travels at a finite speed in all directions. Every other galaxy sees the same thing. Each one sits at the center of its own sphere of visibility. Each one observes galaxies drifting away, farther and faster with distance. This symmetry reveals the deep elegance of cosmic expansion, not a blast, but a flow. The fact that there is no center also means there is no true edge of the universe. The cosmos may be infinite, or it may be finite, but unbounded, like the surface of a sphere that loops back on itself without any edges. Whether infinite or finite, the universe has no outer rim where matter stops. What stops is our ability to see farther, constrained by time and the speed of light. As you exhale, let this idea soften your sense of perspective. We often look for centers, in ourselves, in our planet, in our cosmic home. But the universe invites a gentler understanding. Everything is equally placed, equally drifting, equally part of the expanding whole. The cosmos has no center, but it grows from everywhere. Every point in the universe carries its own horizon. Every star, every galaxy, every world. Not one horizon shared by all, but countless overlapping spheres of visibility, each shaped by the position and age of the observer, each expanding as more ancient light arrives. These horizons are like bubbles drifting through a vast cosmic sea, touching and passing through one another, each revealing a slightly different map of the same unfolding universe. Imagine yourself floating in space, surrounded by a sphere of faint ancient light. Now imagine a distant galaxy, billions of light years away. That galaxy too is wrapped in its own sphere, a glowing boundary of everything that its inhabitants could ever hope to see. Their horizon is centered on them, just as ours is centered on us. Yet our spheres overlap in countless ways, sharing many of the same galaxies but offering different perspectives on their shapes, ages and distances. As you breathe softly, picture these horizons as softly glowing orbs sprinkled throughout space. Some overlap almost completely, others intersect only partially, and some lie so far apart that their spheres contain almost nothing in common. Two regions of the universe separated not by walls, but by the age of the light that has had time to reach them. This layering of horizons reveals something profound about the nature of knowledge in a cosmic sense. Every observer sees their own version of the universe's history. Light that reaches us today may reach another distant galaxy billions of years from now, and light that reaches them now may not reach us until long after our horizon has shifted. The universe's story is not a single shared view, but countless views woven together by the movement of light. It also means that no single observer can ever see the full cosmos, not even in principle. Even if the universe were eternal and we waited forever, parts of the cosmos would remain forever unobservable because their light would always be outrun by expansion. Our horizon and their horizon simply cannot touch. And yet, this is part of the beauty of cosmic structure. Each horizon is like a window carved out of space-time, a frame through which the universe reveals one version of its vast and intricate story. No window is complete, and none is privileged. They simply coexist, billions upon billions of overlapping spheres, each filled with galaxies that appear differently depending on who is watching. As you exhale, let this idea soothe you. You are part of a universe where every point has its own perspective. Every horizon has its own shape. Every observer drifts through their own flowing sphere of light. The cosmos is not one story seen the same way. It is a symphony of countless horizons, all glowing in the dark. When we speak of the edge of the observable universe, it is tempting to imagine a boundary, a kind of cosmic shoreline where existence fades into nothingness. But in reality, the edge we perceive is not a physical border at all. It is an illusion shaped by time, light, and distance. What looks like a limit is simply the farthest moment we can witness, not the farthest place the universe extends. Imagine standing on a quiet beach. The ocean stretches endlessly, but your eyes meet only the horizon, a line where water and sky appear to touch. You know the sea does not end there, yet your vision forms a boundary of its own. The edge of the observable universe is a horizon in the same sense. It is not a cliff at the end of space, but a limit of perception, defined by the age of the cosmos and the time light has had to travel. As you breathe gently, imagine the universe as a vast landscape hidden in deep mist. The parts closest to you are clear, the parts farther away fade softly, and beyond a certain distance, the mist becomes too thick for even the faintest shapes to appear. The universe beyond our observable boundary continues, but its light has not yet reached us, and some of it never will. The edge is really the edge of light's journey, not the edge of reality. This illusion becomes clearer when we consider galaxies whose light we see today. They existed billions of years ago, but they are now far beyond the distance from which light could ever reach us again. They are already outside our cosmic event horizon, We see them only because their ancient photons began travelling before expansion carried them too far away. In a sense, we are looking at signals from places that no longer lie within our future reach, and yet, nothing about this is abrupt or dramatic. There is no sharp line where visibility stops. The universe simply fades gradually into deeper time. The farther away something is, the younger the universe appears, until at last we reach the cosmic microwave background, a soft, glowing veil beyond which the universe becomes opaque to sight. For this reason, the edge we see is not the beginning of the universe, nor the end of it. It is merely the earliest moment light can show us. Everything beyond that boundary, galaxies, clusters, voids, even entire cosmic structures, continues to exist, untouched by our gaze. As you exhale, let this idea flow through you. The edge is not a barrier, it is a horizon. It moves as time moves, shifts as space shifts, and expands gently with every breath of the cosmos. The universe is larger than the picture we see, and the picture we see is only one soft frame in an endless unfolding tapestry. There are regions of the universe whose light will never arrive, not now, not in 1,000,000 years, not even if we waited for eternity. These are not places lost in darkness, nor regions without stars, but parts of the cosmos carried away so swiftly by expansion that their light is forever swept backward, unable to bridge the growing distance. Their stories exist, but their messages cannot reach us. Imagine standing on a shoreline watching waves roll toward you. Most reach your feet, one after another, but far out at sea there are gentle ripples that never touch the sand. They begin too far away, or the tide pulls them back before they can arrive. The universe behaves in much the same way. Beyond a certain distance, even the fastest wave of light is pulled away by cosmic expansion, faster than it can move toward us. As you breathe softly, imagine those distant photons, tiny messengers born in brilliant stars or luminous galaxies, trying to cross a widening sea of space. With each moment, the space between grows larger. Their wavelength stretches, their energy thins, and eventually they can no longer make progress. They are carried away, like a whisper lost to wind. This boundary, where light can no longer reach us, defines our cosmic event horizon. Anything beyond it is present in the universe but absent from our future. We may see some of these galaxies as they were billions of years ago, because their ancient photons left before expansion accelerated. But we cannot see them as they are now, or as they will ever become. Their future light is gone to us, forever receding. This reveals something profound and humbling. The observable universe is not static. It is slowly changing, shrinking in terms of how much of the cosmos will ever remain visible. Galaxies cross beyond the event horizon, not disappearing from existence, but disappearing from possibility. Their radio waves, their starlight, their supernovae, all these signals may continue, but they flow outward in the wrong direction, unable to overcome the growing cosmic tide. And yet, there is softness in this truth. The universe is not vanishing. Our connection to it is simply evolving. We remain part of the same cosmic whole, even if we cannot exchange light with all of it. Consider this quiet reflection. Some stars we see tonight have already crossed beyond the reach of future communication. Some galaxies shining faintly in our telescopes are already out of touch. Their light is a message from a past we can still receive, but their present has slipped away. What does it mean to be part of a universe where most of it is forever beyond sight? Perhaps it teaches us that beauty does not require ownership, only awareness. That wonder can exist even in things we cannot reach. There is light that will never find us. But the knowledge of its existence still fills the universe with meaning. As we drift through the quiet outskirts of the observable universe, another presence makes itself known. Subtle, invisible, yet profoundly influential. It does not shine. It does not gather. It does not form stars or galaxies. And yet it shapes the fate of the cosmos more than gravity itself. This mysterious presence is dark energy, the quiet force behind the accelerating expansion of space. Imagine holding a balloon in your hands. At first it expands gently. Then, without warning, the expansion speeds up, as if some unseen force has begun pushing from within. Our universe behaves in a similar way. For billions of years, cosmic expansion slowed under the pull of gravity. But around 5 billion years ago, something changed. The expansion began to accelerate, as though the universe was suddenly breathing out more forcefully, pushing galaxies apart with increasing speed. This acceleration is driven by dark energy, a form of energy woven into the very fabric of space. As space grows, dark energy does not thin out the way matter does. Instead, its presence remains steady, creating a persistent outward push. The more space expands, the more influential dark energy becomes, gradually overpowering gravity on the larger scales. As you breathe gently, imagine this influence as a soft, constant wind flowing through space. It does not roar or surge, it simply persists, shaping the motion of galaxies with a whisper rather than a shove. Over time, this whisper becomes the dominant rhythm of the cosmos. The effects are profound. Distant galaxies drift away more quickly. Some cross the cosmic event horizon, slipping beyond the reach of future communication. Large-scale structures become isolated, like islands in a widening ocean. The universe becomes more spacious, more diffuse, more quietly stretched. And yet, dark energy reveals itself only through the motion of cosmic expansion. We cannot see it, we cannot touch it. But by observing how galaxies move, by measuring the growing gaps between clusters, and by studying the faint imprint of expansion on ancient light, we can trace its influence across billions of years. Dark energy also transforms our understanding of the future. If it remains constant or grows stronger, the universe will continue accelerating indefinitely. Over trillions of years, distant galaxies will fade entirely from view. Even the closest clusters may drift beyond reach, leaving only a small pocket of gravitationally bound galaxies visible to future observers. This is not a frightening fate. It is a gentle unfolding, a slow, graceful stretching of the cosmic tapestry. Dark energy does not destroy or disrupt. It simply guides the expansion, shaping the horizon of what can be seen. As you exhale, consider how something so invisible can influence everything. Dark energy reminds us that not all forces in life announce themselves loudly. Some shape us quietly, subtly, persistently, changing the world with a whisper rather than a sound. In our everyday experience, distance is simple. A kilometre, a mile, a few steps across a quiet room. All these are measures we can hold in our minds. But in the cosmos, distance becomes something stranger, more fluid, more deeply tied to time and the expansion of space itself. The numbers grow so vast and the concepts stretch so far beyond intuition that the universe gently asks us not to understand with logic alone, but with imagination. Imagine two galaxies separated by a gulf of billions of light years. The light we see from them today began its journey when the universe was young, yet those galaxies are now much farther away than they were when that light first left. The fabric of space has stretched underneath them, carrying them outward like leaves drifting apart on an ever-widening river. A galaxy whose light has travelled for 13 billion years might now sit 30 or 40 billion light years away, or more. How can something be farther than the number of years its light has travelled? Because space is not a stage on which objects simply move. It is a living fabric that expands, stretches and grows even as light crosses it. The path light travels today is not the path it would have followed billions of years ago. The river widens even while the ripple moves. As you breathe slowly, imagine the universe as a giant canvas made of soft, flexible cloth. Place 2 dots on it. Now stretch the cloth gently. The dots move apart not because they slide across the surface, but because the canvas itself expands. If you released a tiny beam of light from one dot toward the other, the cloth would continue stretching while the light travelled. By the time the light arrived, the distance between the dots would be greater than the journey the light had taken. This is how cosmic distances defy intuition. A light year is not a static measurement. It is a record of how long light has been in motion, but in an expanding universe, the space that light crosses is never still. It grows beneath the photons, expanding the gap faster than the light can shrink it. And so, when we speak of galaxies 46 billion light-years away, we're not describing how far light has travelled. We're describing how far space has been stretched since that light first began its long journey. These distances soften our sense of scale. They invite us to release rigid notions of near and far, here and there. In the cosmic perspective, distance is not just separation. It is history, expansion, and the ongoing evolution of the universe's vast fabric. As you exhale, let the strangeness feel gentle rather than overwhelming. The universe does not ask you to fully grasp these distances, only to feel their quiet immensity, like standing at the edge of a vast ocean whose farthest shores lie forever beyond sight. In a cosmos where space itself expands, distance becomes a story, not a number. The universe is not simply expanding, it is growing into itself, unfolding like a slow, cosmic blossom. Each moment brings more space, more distance, more room for galaxies to drift and evolve. This growth is not violent or sudden, it is gentle, patient and steady, like a long exhale that has continued for billions of years. Imagine a river that widens as it flows downstream. Boats floating on its surface drift apart, not because they paddle away from each other, but because the water beneath them spreads. In the same way, galaxies move apart not through motion, but through the expansion of the space in which they rest. The universe grows everywhere at once, stretching evenly across its entire volume. As you breathe softly, imagine this expansion not as a force pushing things outward, but as new space appearing between every pair of distant points. The growth is uniform, impartial, and continuous. Even regions without galaxies, as just the empty cosmic voids, expand in the same serene rhythm as the dense clusters of stars. The universe grows both in its emptiness and its fullness. This growth also means that the cosmos evolves in a way unlike anything we experience on Earth. The size of the universe is not a fixed property. It depends on when you measure it and from where you observe it. A galaxy 10 billion light-years away today might be 30 or 40 billion light-years away tomorrow, not because it moves quickly, but because the distance itself lengthens. As the universe grows, structures within it respond differently. Galaxies bound by gravity remain close, orbiting and merging. Clusters hold together, forming massive cosmic cities of stars. But beyond the scale where gravity binds, expansion takes over. Filaments stretch, voids widen. The cosmic web becomes more diffuse. Over trillions of years, this slow stretching will isolate every gravitationally bound region, turning local clusters into quiet islands floating in an ever-widening sea of space. This idea, that expansion affects the vast but not the small, is one of the universe's quiet paradoxes. The atoms in your body do not expand. Planets, stars, and galaxies do not stretch. Their internal gravity keeps them whole. But the spaces between superclusters feel the universe's growth fully, widening into vast silent plains of emptiness. And so, the universe grows into itself, not like a balloon with a centre, but like a limitless fabric that expands everywhere at once. There is no central point of origin anymore, no direction in which expansion is stronger. It is a universal, gentle unfolding. As you exhale, Imagine this growth as a slow pulse, a rhythm older than stars shaping space with quiet consistency. The universe expands not outward, but inward and everywhere, filling itself with new space and new possibilities. It grows not to escape anything, but simply because growing is what the cosmos does. The observable universe is not eternal in the form we see today. Its boundaries shift, its contents change, and its future will look very different from its present. Though the cosmos continues to expand, the portion of it that remains visible, reachable by light, will slowly narrow. Over billions and trillions of years, the observable realm will become a smaller island within a much larger unreachable sea. Imagine looking out over a city at night. Lights stretch across the horizon in every direction. But imagine that, slowly and silently, the farthest lights begin to fade. Not because they turn off, but because the fog grows thicker between you and them. One by one, those distant lights blur and vanish, until only the closest ones remain. This is the future of our night sky. As dark energy continues to accelerate the expansion of space, distant galaxies will recede faster and faster. Many have already crossed the event horizon, meaning their present and future light will never reach us. Over time, more galaxies will follow. Their glow will stretch into longer wavelengths, dimming until even the most sensitive instruments cannot detect them. As you breathe slowly, imagine the cosmic web thinning. Galaxies at the farthest edges of our view fading into darkness, clusters drifting silently out of reach. The universe does not grow emptier, but our connection to it does. We become an island in cosmic space, bound together with nearby galaxies by gravity, even as the rest of the universe slips away. In the unimaginably distant future, only the local group, our Milky Way, Andromeda, and a handful of smaller galaxies, will remain visible. Everything else will have faded into the dark beyond the horizon. The night sky will no longer be a sprawling tapestry of billions of galaxies. It will be a smaller, quieter scene, a cosmic village surrounded by an ocean we cannot cross. And yet, this fate is not somber. It is part of the natural rhythm of an expanding cosmos. Our observable universe shrinks not because the universe dies, but because it grows ever larger, stretching beyond the reach of light. We often think of the observable realm as the whole universe, but it is only a temporary window, a momentary frame showing the small part of the cosmos that light has had time to reveal. As the universe ages, that window will shift, narrow, and darken, but the grandeur it once revealed will remain part of the universe's story, if not part of our own view. As you exhale, let this perspective settle. We live in a time when the universe is remarkably visible. We see galaxies billions of light years away, stars forming at the dawn of time and the afterglow of creation itself. This clarity is a brief moment, a luminous chapter in a much longer cosmic book. The fate of the observable realm is not a loss, but a reminder to wonder while the sky is open. Even as we travel to the farthest edges of what light can show us, a quiet truth hums beneath everything we've explored. The universe is almost certainly far larger than the observable sphere surrounding us. Much larger, perhaps infinitely so. The cosmos we can see, this 46 billion light-year bubble of memory and light, is only a tiny portion of a vastly grander reality. A fleeting window into a structure that extends far beyond the reach of vision or theory. Imagine standing in a meadow surrounded by thick fog. Only a small circle of landscape is visible. A few trees, a patch of grass, a slice of sky. But you know the world continues beyond the mist. The mountains, the rivers, the forests are all there, hidden but real. The observable universe is that circle of clarity, the cosmic fog created by time and the speed of light, hides everything beyond it. As you breathe gently, imagine that fog thinning just slightly, Not enough to reveal everything, but enough to sense the vastness beyond. Like a whisper at the edge of hearing, the universe hints at realms far beyond our horizon. Galaxies that will never send light our way, clusters that drift in their own distant webs, and perhaps structures so immense they dwarf anything within our reach. Inflation theory suggests that the universe expanded far beyond the size of our observable bubble, so far in fact that what we see is only one tiny patch of an unimaginably larger whole. Our visible universe could be just a grain within a cosmic landscape that continues for trillions of light years in every direction. The true scale may be impossible to picture, not because it is complicated, but because it is so profoundly vast that human intuition dissolves in its presence. In some models, the universe might even be infinite, a boundless ocean of galaxies, repeating patterns, or entirely unique regions that never interact. Some patches could have different densities, different arrangements of matter, perhaps even different large-scale features shaped by early quantum fluctuations stretched across unimaginable distances. And yet, in this immensity, we occupy a perfectly ordinary place, not central, not privileged, simply one region of a vast, flowing cosmos. The idea of a universe larger than imagination is not meant to overwhelm. It is meant to soften the edges of what we think we know. It shows us that the boundaries we perceive are temporary, shaped by time and light, not by the true reach of existence. As you exhale, let this thought expand gently within you. We see only a small window, but the universe continues far beyond it, stretching into regions we will never touch, never see, never measure, and yet they exist, unfolding in calm, silent grandeur. The universe is large enough to hold every dream of wonder you've ever carried, and then larger still. The edge of the observable universe may seem like a fixed boundary, a final circle beyond which nothing can be seen. But this boundary is not static. It is a moving frontier, shifting outward every moment as new ancient light completes its long journey and reaches us. Even while distant galaxies fade beyond the event horizon, the past continues to reveal itself, one photon at a time. Imagine sitting beside a window on a foggy morning. As the sun rises, the mist thins, and shapes appear at the edge of your vision. A tree, a distant fence, a curve of the landscape. Not because the world is moving closer to you, but because more light is now reaching your eyes. The universe behaves in the same soft, expanding way. What we can see grows not because we travel outward, but because time allows ancient light to finally arrive. As you breathe slowly, imagine this boundary expanding with each inhale. A photon emitted nearly 14 billion years ago, perhaps from a tiny galaxy in the universe's youth, may be reaching us tonight for the very first time. Its entire journey has been a patient crossing of space as that space stretched beneath it. The universe shifts, grows and unfolds, and with it, our cosmic horizon shifts too. This moving frontier exists because light has a finite speed. The universe is 13.8 billion years old, but because space has expanded the entire time, the farthest regions whose light is reaching us now lie roughly 46 billion light years away. Tomorrow, that shell of visibility will expand slightly farther. The next day, farther still. The edge moves because time moves. As long as the universe has more ancient photons travelling inward, the boundary will continue to grow. And yet, there is a quiet balance. While our observable horizon expands into the past, our event horizon restricts our view of the future. We can see more of the early universe over time, but less of the distant present. Some galaxies we observe today will eventually fade beyond reach, even as new ancient light takes their place on the outer shell of visibility. It is a beautiful paradox. We learn more about the early universe as time passes, even while the universe becomes less connected to us. This moving frontier is not a wall. It is a wave of discovery, a delicate ripple where past and present meet, shaped by light and the slow unfolding of cosmic time. As you exhale, let the idea comfort you. The universe is always offering something new, even if that new is billions of years old. Our horizon grows not through motion or effort, but simply by letting time flow. The edge is not fixed. It is alive, shifting quietly with every heartbeat of the cosmos. As we drift through the vastness of the cosmos, past galaxies and voids and horizons shaped by time, something gentle becomes clear. The idea of an edge is not only a cosmic concept, it is a deeply human one. Just as the observable universe has boundaries created by time and perception, each of us carries our own inner horizons, shaped by memory, awareness, and the limits of what we can understand. Imagine standing at the edge of a quiet lake at dusk. The surface reflects the fading sky, but only up to the point where the light allows. Beyond that, the water becomes shadow, a soft blur where details dissolve. Our minds work this way too. We see clearly the experiences close to us, the memories still warm within our thoughts. But as we look farther back, into childhood, into distant moments, into forgotten dreams, the details become softer, dimmer, like galaxies at the edge of a personal universe. As you breathe gently, imagine your awareness as a sphere of light. The thoughts nearest to you are bright and familiar. Farther out lie ideas still forming, faint sparks of curiosity awaiting discovery. And beyond that, in the quiet outer regions, are possibilities you have not yet imagined, the unexplored territories of your own inner cosmos. Just as every observer in the universe has their own observable sphere, every person carries a unique horizon of experience. No two perspectives are the same. No two horizons overlap perfectly. We each see the world through a window shaped by the time we've lived, the light we've received, and the stories we've carried with us. And these inner horizons, like the cosmic one, are not fixed. They expand as we learn, shift as we grow, reseed as certain memories drift into the past. With each moment, your inner universe evolves. The boundary of what you understand moves outward, just as ancient light continues to expand the edge of the observable cosmos. The unreachable universe has its analogue within us too. There are parts of ourselves hidden, not because they are absent, but because we have not yet had the time or perspective to reach them. There are dreams waiting like distant galaxies, invisible for now, but real, and one day perhaps illuminated by new light. As you exhale, slowly let this reflection settle. The cosmos outside mirrors the cosmos within. Its boundaries shift just as ours do. Its light arrives in layers, just as insight arrives gradually into our lives. The edge within each of us is not a limit. It is an invitation to wonder, to grow, to expand the sphere of who we are. Infinity is one of the most humbling ideas the universe offers us. It stretches beyond calculation, beyond imagination, beyond anything we can measure or fully comprehend. Yet infinity is also gentle. It does not demand that we understand it. It simply asks us to sit with its presence, the way we might sit beneath a night sky that feels too vast for words. Imagine lying on soft grass beneath the stars. The more you look, the more the sky seems to open, expanding in all directions. No matter where your eyes wander, there is always more depth, more darkness, more distant light. This feeling, that quiet sense of endlessness, is the human echo of infinity. As you breathe slowly, imagine infinity not as a concept, but as a calm landscape. It is the sense that the universe does not end where our sight ends, that every horizon hides another horizon beyond it, that no matter how far we travel, the cosmos continues to unfold, softly and without urgency. Infinity also connects deeply with the quiet mind. Just as the universe expands, our thoughts expand. just as cosmic horizons shift, our inner horizons shift, and just as the universe introduces no true boundary, our minds can grow without one, learning, healing, changing, reaching toward new understanding with no final endpoint. When we contemplate infinity, we often imagine something overwhelming, but in truth, infinity is peaceful. It removes the pressure of completion. It tells us there is no final moment where understanding stops, no fixed limit to how far curiosity can reach. The universe is not asking us to grasp everything, only to be present with what we can see. Infinity also softens the ego. It reminds us that we are small but not insignificant. We are brief but not meaningless. We exist within an endless unfolding, but we carry awareness, the ability to witness, to wonder, to feel. In a universe without boundaries, consciousness becomes a kind of anchor, a quiet center from which we perceive the vastness around us. Consider this. If the universe is infinite, then somewhere, in some distant region beyond all reach, galaxies form just as they do here. Stars burn, planets orbit, light travels, life might arise, and yet none of this diminishes our experience. Instead, it highlights a beautiful paradox. We are both tiny and connected to something without end. As you exhale, feel the spaciousness within you widen. Infinity is not cold or foreign. It is the same openness you feel in moments of deep calm, when your thoughts dissolve into quiet and your awareness expands without trying. Infinity is both around you and within you, a reminder that existence has no edge, and neither does the mind that contemplates it. Light is more than illumination. It is memory. The universe's oldest archivist, carrying stories across billions of years. Every photon that reaches us is a fragment of yesterday, a tiny messenger from some distant moment. Time, meanwhile, is the river that carries these memories forward, flowing without haste, without pause, shaping our perception of everything we see. Imagine holding a small glass sphere in your hand. Inside it, faint shapes drift, glimpses of events long past suspended like fireflies in amber. Light behaves this way. When we look at a star, we're not seeing it as it is now, but as it was when the light left its surface. When we look at a galaxy billions of light years away, we are witnessing a scene from a universe young and unsteady, a moment preserved in the gentle persistence of photons. As you breathe softly, imagine time as a slow current, carrying all things forward while light moves through it, gathering and preserving the impressions of cosmic history. The edge of the observable universe is not just a boundary in space, it is a boundary in time. The farther out we look, the farther back we travel, until eventually we reach the soft glow of the cosmic microwave background, the oldest visible memory of all. Light allows us to peer into epochs we could never visit. Its journey is long and fragile, shaped by expanding space, stretched into redder wavelengths, filtered through cosmic dust, and absorbed or scattered along the way. But some photons endure the entire crossing, unchanged except by the universe's gentle growth. They arrive carrying the texture of time itself. Time, meanwhile, gives structure to everything. It is the quiet force that ensures light has a direction. It is what allows memory to exist at all. Without time's flow, stories could not unfold, stars could not evolve, galaxies could not form, and we could not witness the universe's grandeur in motion. Together, light and time create a tapestry, one woven from both presence and absence, from what is seen and what has slipped beyond sight. The universe uses light to paint its past, and time to carry that painting across billions of years until it reaches the eyes or instruments of a curious mind. As you exhale, imagine the memories carried by every photon around you. Some began their journey long before Earth existed. Some come from stars still shining. Some come from stars that no longer burn. And some come from the very dawn of visibility. Light is the universe remembering itself. Time is the universe flowing forward. And you, in this quiet moment, are a meeting point of both. A place where cosmic memory and cosmic motion arrive and become experience. What would we see if we could drift beyond the observable horizon, past the cosmic limit defined by light and time? What sights would unfold in the uncharted regions where photons have not yet arrived, where the universe continues without our observation? Although physics tells us we cannot cross this boundary, imagination allows us to wander there gently, guided by the cosmic patterns we already know. Imagine floating at the very edge of what is visible, the cosmic microwave background glowing softly behind you like a warm sunset from the first dawn. Just beyond that faint veil lies a realm untouched by light's arrival, a region of pure possibility. If you drifted forward, you would not find emptiness, but continuation, galaxies forming, clusters shaping, dark matter folding space into familiar patterns. As you breathe softly, picture drifting deeper into this unlit region. The universe does not suddenly change. There is no border, no wall, no moment where physics shift sharply. Events unfold much as they do here. Stars ignite, dust gathers, gravity sculpts, and cosmic filaments extend like roots across unimaginable distances. You would find galaxies whose light has not reached as yet, not because they are too dim or too small, but simply because their photons have not had enough time to complete the long journey. Some galaxies might look slightly younger, shaped by conditions subtly different from the early universe we can observe. Some regions might carry variations in density or temperature, remnants of quantum ripples stretched by inflation, all of it familiar, yet unobserved. Even farther out you might encounter structures far older than anything we can detect today. Cosmic inflation could have stretched space so dramatically that regions beyond our horizon experienced entirely different histories before settling into the calm expansion we see. The differences would likely be subtle, tiny divergences in density or temperature, but even small changes given billions of years can shape vastly different cosmic landscapes. And beyond these distant regions, beyond even the faintest echo of the early universe, lies the possibility of something stranger, patches of space where inflation ended at slightly different times, creating bubbles of cosmos with their own conditions. These regions, if they exist, would drift forever beyond our reach, neighbouring universes, quiet and separate, sharing no light with ours. As you exhale, let this imagined journey soften into calm awareness. We cannot travel beyond the horizon. We cannot receive light from those distant realms. But the patterns we see here, the filaments, the galaxies, the voids, tell us that the universe beyond our sight likely follows the same quiet symphony of physics and time. To drift beyond the horizon is to imagine endless continuation, a universe without edges, flowing gently into more of itself. As we travel to the very limits of the observable universe, another question begins to glow softly in the background, a question whispered by physics, imagination, and the lingering mystery of existence itself. Could there be other universes beyond our own? Entire realms with their own beginnings, their own horizons, perhaps even their own versions of time, matter, and light. This idea is not science fiction alone. It grows naturally from several theories: cosmic inflation, quantum mechanics, and the mathematics of higher dimensions, each offering a quiet hint that our universe may be just one room in a far larger cosmic structure. Imagine blowing a single soap bubble into the air. Now imagine that bubble forming beside countless others, each expanding, drifting, shimmering with its own surface and pattern. Some might collide gently, some might remain forever separate. Cosmic inflation suggests something similar, that our universe may be one bubble among many, each formed in a much larger inflationary sea. As you breathe softly, picture these universes not as places we can visit, but as isolated cosmic blossoms, each expanding internally, each with its own laws or constants. Some may resemble ours closely, others might differ in ways so profound that matter as we know it could not form. Quantum mechanics offers another whisper. At the smallest scales, reality behaves like a branching wave, with outcomes diverging into multiple possibilities. Some interpretations imagine that these branches are not hypothetical but real, parallel universes where every possible outcome unfolds. In that view, the cosmos is not a single story, but a vast library of narratives, each written in its own quiet volume. We cannot observe these other universes. Their light cannot reach us. Their space is not connected to ours. And yet the mathematics that describes our universe does not forbid them. In fact, some theories find greater simplicity and beauty when multiple universes are allowed, as though the cosmos expresses its creativity not once, but endlessly. If other universes exist, what does that mean for us? It does not diminish our place. It does not make our universe less special. Instead, it invites a gentler perspective, that creation might be abundant, generous, and diverse beyond anything we can imagine. As you exhale slowly, allow the possibility to drift through your thoughts like a soft breeze. The existence of other universes is not something we need to solve or understand fully. It is a quiet reminder that the cosmos may be far richer and more layered than the single horizon we observe. We live in one universe, but reality itself may be an ocean of universes, each drifting through its own silent expanse. Among all the wonders of the cosmos and the galaxies, the filaments, the ancient light and the unreachable horizons, one truth glows quietly beneath everything. The universe has grown eyes through you, through your awareness, your thoughts, your ability to notice and wonder. The cosmos observes itself. You're not separate from the universe. You're a way in which it becomes conscious of its own vastness. Imagine a wave rising on the surface of a great ocean. The wave is not separate from the sea. It is the sea in motion, expressing itself in a temporary form. In the same way, consciousness is not separate from the universe. It is the universe, arranged into a pattern capable of reflection, curiosity and awe. As you breathe softly, consider the atoms that form your body. They were once the dust of ancient stars. Before that, they were particles formed moments after the Big Bang. You carry the same ingredients as galaxies, nebulae, and the distant cosmic glow. The universe did not create life as an afterthought. It evolved into life as a natural unfolding of its own complexity. When you look at the night sky, the starlight entering your eyes is older than any human story. When you reflect on that light, when you feel wonder, calm, or connection, the universe is sensing its own history through you. Your awareness makes the cosmos more than an expanse of matter. It becomes something capable of meaning. This is not metaphor alone. The very structure of the human brain mirrors the branching patterns found in cosmic webs. Neurons fire like miniature stars. Networks form like galactic filaments. Even at the level of structure, the universe repeats itself, echoing patterns across scales so different they seem unrelated, and yet they reflect the same underlying harmony. What does it mean that the universe can contemplate its own origins? It means that consciousness is not an accident. It is an emergent property of cosmic evolution, a natural result of matter organizing, cooling, and arranging itself into complexity. In you, in every listener breathing quietly right now, the cosmos finds a moment of stillness and reflection. As you exhale, let this idea wash gently over you. You're not simply in the universe. You are of the universe. Your thoughts are shaped by cosmic history. Your senses are tuned to cosmic light. Your existence is a continuation of the same processes that formed stars and galaxies. When you wonder about the universe is wondering about itself. Your awareness is a bridge between the immense and the intimate, a place where stardust becomes conscious and silence becomes meaning. You are a moment of cosmic self-recognition, a breath of the universe made aware. For all our instruments, equations, and cosmic maps, there is a simple truth woven through the universe. We will never fully know it. Not because we lack intelligence or curiosity, but because the cosmos is too vast, too deep in time, too rich in mysteries that lie forever beyond the reach of light. And yet there is a profound beauty in this unknowability, a quiet invitation to wonder without needing to possess every answer. Imagine walking through a forest at dusk. You see the path in front of you, the soft shapes of trees, the fading light. But beyond the reach of your vision, the forest continues, filled with unseen creatures, hidden roots, the quiet motion of things you cannot name. Your inability to see everything does not diminish the forest, it enriches it. It leaves space for imagination, for humility, for awe. The universe is like that forest. At every scale, from quantum particles to cosmic filaments, new mysteries appear just as others are solved. Beyond our horizon lies an infinite landscape of possibilities that will forever remain outside our measurements. Some galaxies will always be hidden. Some cosmic epochs will always be invisible. Some answers will always rest in silence. As you breathe slowly, let this realization feel gentle rather than frustrating. The purpose of wonder is not to conquer mystery, but to live peacefully alongside it. Not knowing everything does not limit us. It frees us from the illusion that the universe must be fully understood to be appreciated. In fact, uncertainty is part of what makes the cosmos feel alive. If everything could be known, the universe would become small, rigid, confined to what fits within our understanding. Instead, the cosmos remains boundless, vast beyond comprehension, dynamic beyond prediction, rich with layers we have not yet dreamed of exploring. Even scientific progress honours this uncertainty. Each answer leads to deeper questions. Each discovery reveals new horizons. Every insight into dark matter, dark energy, or cosmic inflation illuminates more mysteries than it resolves. This is not a failure. It is the delicate rhythm of human curiosity meeting an infinite universe. And beyond science lies something even softer, the emotional beauty of not knowing. When you look at the night sky, your mind is free to drift across possibilities. You're allowed to feel small without feeling insignificant, allowed to imagine without limits, allowed to rest in the idea that some truths are too vast to be held, yet close enough to be felt. As you exhale, let the unknown become a comfort, a reminder that you are part of a story much larger than one lifetime, one species, or one planet. A story still unfolding, with chapters written in light we have not yet received. There is beauty in not knowing, a beauty that gives wonder room to breathe. The edge of the observable universe is not a barrier meant to confine us. It is an invitation, a soft reminder that beyond every horizon lies more to imagine, more to question, more to feel. The cosmos does not place limits to discourage curiosity, but to inspire it. Every boundary we encounter becomes a doorway into deeper wonder. Imagine standing at the end of a long pier stretching into a quiet ocean at night. The water is dark, the air is cool, and far beyond the reach of your eyes, the sea continues in gentle, endless motion. The horizon looks like an ending, but the truth is that it marks only the beginning of everything you cannot yet see. The universe's edge is the same, a place where vision fades but imagination begins. As you breathe slowly, picture standing at the edge of the observable universe. Behind you lie galaxies, clusters, filaments, and the long history of light we have followed on this journey. Ahead lies a realm without form, not because it is empty, but because its light has not reached us. In that unseen expanse, stars burn, worlds orbit. galaxies collide and cosmic webs stretch farther than any map can show. The edge is not an ending. It is a quiet threshold between the known and the unknowable. Every horizon in life works this way. We often meet the limits of our understanding, our experiences, our memories, not as walls but as invitations to grow, to learn, to expand the boundaries of our inner cosmos. Just as light reveals the universe one photon at a time, we reveal our own depths one moment of awareness at a time. The cosmic edge also invites humility. It reminds us that the universe is vast enough to hold mysteries we may never touch, and yet gentle enough to share glimpses of its history through faint, patient light. We are allowed to explore, but also allowed to rest, knowing that we do not need to reach every horizon to feel connected to the whole. As you exhale, consider how much beauty arises precisely because we cannot see everything. The hidden sparks imagination. The unseen deepens curiosity. The unreachable gives shape to our dreams. If the universe revealed itself entirely all at once, there would be no room for wonder, but instead it reveals itself slowly, a soft unfolding across time, inviting us to walk alongside it, discovering just enough to stay curious, just enough to stay humble, just enough to keep drifting forward. The edge of the observable universe is an invitation to look farther, to think deeper, and to feel the quiet joy of being part of something immeasurably large. In a universe so vast that even light cannot cross it in time, it's easy to feel small, a brief flicker of awareness in an ocean of galaxies. But smallness is not insignificance. In the quiet unfolding of the cosmos, every point, every moment, every life becomes part of a larger, expanding story. And you, right now, are a bright thread woven into that tapestry. Imagine a single star glowing in the night sky. Its light takes years, sometimes centuries, sometimes millennia to reach your eyes. And yet, when you look at it, that light completes its journey, fulfilling a purpose written into its very existence. You are the final witness, the receiver of a story billions of years old. In the same way, your awareness completes the story of the universe simply by noticing it. As you breathe gently, consider this. You're made from the same atoms that fill the cosmic web. The calcium in your bones was forged in ancient stars. The iron in your blood was born in supernovae. The carbon that shapes your thoughts, your memories, your voice, all of it drifted through space long before Earth formed. You're not separate from the universe's expansion. You're part of it. Every breath you take is part of the same cosmic rhythm that stretches galaxies apart. Every thought is a tiny ripple in the vast field of consciousness that the universe has grown through its own evolution. Your place in the cosmic story is not defined by scale, but by connection. A galaxy does not need to be aware to exist. A star does not need to reflect on its own light. But you can. In you, the universe becomes curious. In you, the universe becomes contemplative. In you, the universe pauses for a moment, looks inward, and marvels at itself. And this moment, this quiet listening, is part of the story too. The expanding universe is not only a map of galaxies drifting apart. It is a story of emergence, from particles to atoms, from atoms to stars, from stars to worlds, from worlds to life, and from life to awareness. You carry this entire sequence within you. Your existence is the continuation of a cosmic lineage stretching back to the very first light. As you exhale, let this reflection settle deeply. You do not stand outside the cosmic story looking in. You're inside it, shaped by it, contributing to it in ways both quiet and meaningful. Your curiosity, your wonder, your presence, all of it is a part of the universe expanding not just in space, but in understanding. You're a moment of clarity in the cosmos, a brief, beautiful pause in which the universe becomes aware of its own unfolding. We began this journey with a simple, poetic question. Where does the universe truly end? After drifting through galaxies, horizons, ancient light, and the deep silence of cosmic voids, the answer becomes clearer and softer. The universe does not end where our vision ends. The edge we see is only the edge of light's long journey toward us. Beyond it, the cosmos continues in quiet, unreachable expanses. The limit is not physical but temporal, not a wall but a horizon. Imagine once more standing at the shore of a dark ocean. You can see only as far as the moonlight allows. The rest of the sea remains hidden, yet unmistakably real. The horizon is not the ocean's boundary, only the limit of your perception. In the same way, the observable universe is a circle drawn by time and light, not by the end of existence. As you breathe slowly, let this realization fold gently around you. The edge of the universe is simply the farthest moment we can witness, a moment frozen from a younger cosmos, carried to us by the patience of photons travelling across billions of years. These photons form the outer shell of our observable sphere, a soft, luminous horizon we can never physically reach, yet we can contemplate from afar. Throughout this journey, we've explored how horizons shift with time, how some galaxies drift beyond reach even as ancient light continues to arrive, how every observer everywhere sees themselves at the centre of their own visible cosmos, and how the universe grows into itself, creating more distance, more mystery, more room for wonder. Now, returning to the first question, we understand something essential. There is no single edge. There is only the boundary of what light has had time to show us. Beyond that horizon lies a continuation of the same cosmic story. Galaxies forming, stars shining, space expanding, whether or not their light ever reaches our eyes. This realization offers a quiet comfort. We don't need to see everything to feel connected to the whole. We don't need to know every answer to feel the presence of the infinite. The universe leaves room for mystery because mystery is part of its beauty. It gives wonder a place to live. As you exhale, let the journey drift through your thoughts one last time. The earliest galaxies, the ancient microwave afterglow, the silent voids, the unreachable realms, and the horizon shaped by time rather than walls. The question we began with still stands, but now its meaning has softened. Where does the universe end? It doesn't. Only our vision does. And even that boundary moves with every breath of time. As our journey reaches its quiet conclusion, imagine yourself drifting at the soft edge of the observable universe, a place not defined by darkness, but by distance, by time, by the gentle limit of ancient light arriving after billions of years of travel. Behind you lies everything we have explored together. The galaxies, the filaments, the cosmic microwave glow, the unreachable realms carried away by expansion. Ahead of you is only silence, not emptiness but possibility, waiting for light that will never quite reach us. Take a slow breath. Let the immensity soften. Let the distance blur into calm. The universe does not end here. It simply fades into a stillness we cannot see, a continuation beyond our ability to perceive. Just as twilight does not mark the end of the day, only its gentler form, the cosmic horizon marks not the end of existence, but a shift into the unseen. And in that unseen realm, the universe continues its quiet rhythms. Stars ignite, galaxies evolve, space stretches, and time flows steadily forward. You stand, in imagination, in a place where the universe becomes a whisper, a boundary where light thins into the faintest glow, where the ancient past touches the edge of the never-seen. Here, the vastness no longer feels overwhelming. It feels peaceful, natural, like an exhale that has taken 13.8 billion years to complete. As you breathe gently, consider how every horizon we explore tonight mirrors something within yourself. You too have boundaries shaped by time. You too carry memories travelling across the years. You too have regions of your inner life still dark, still untouched by illumination, not because they do not exist, but because their light has simply not reached you yet. And just as the universe expands, so do you, growing quietly, softly, patiently, letting new understanding arrive when it is ready, the way ancient photons finally reach our eyes after crossing the vastness of space. The cosmos is not separate from you. It is the story you were born from, a story still unfolding, a story that continues long after this moment ends, long after your awareness drifts towards sleep. So let the universe fade gently into rest. As you fade with it, let the horizon soften, let the quiet deepen, let your thoughts dissolve like starlight at dawn. You've travelled far tonight, farther than light itself can reach in a lifetime, and now it is time to return to the simple rhythm of your breath. The cosmos will keep expanding, the galaxies will keep drifting, and you for now can let go. Everything flows, sleep in that motion,